So what are we doing right now? We are practicing the past paper questions on the equations of motions SUVAT. This is our practice question number 2. We are taking the past paper questions from the AS Physics, and these are your equations of motions. Alright, so this is a long question. It is split across various screens. I'll show you the question completely. You can take the snapshots. Try to attempt the question yourself, pause the video, attempt the question yourself, come back to the video, play it to look at how I'm working on this question to clarify your understanding. So this is screen 1, screen 2 of the question, and the screen 3. Alright. Meanwhile, please do not forget to subscribe to the channel because it is really helpful in many ways, as well as please do comment in the chat box your feedback on the quality of the videos. If you have any suggestions, please feel free to share, and if you have some appreciation, please do not forget to mention it. Okay, so let us start. So I hope you have solved the question and you are back again, you have played the video again. So what is happening in the question? Let us understand. A ball is thrown from A to B as shown in this figure. The ball is thrown with the initial velocity v at 60 degrees. So it is thrown at a velocity v and the angle is also given. The variation with the time t of the vertical component of the velocity of the ball from time t is equal to 0 to time t is equal to 0.6 seconds is shown in this figure. So this is your velocity time graph, but what kind of information do you get from this velocity time graph? You are getting the information about the vertical component. This is the vertical component on the y-axis given here. Right? So where do you find the vertical component? This is your vertical component. Any velocity which is at an angle, it can be derived into vertical component and a horizontal component, like this. So the velocity time graph given here is only for the vertical component. So what does the theory about the vertical component tells us? As you are moving in a trajectory, the vertical component keeps changing. The vertical component changes, and if you see here, the vertical component is changing in magnitude from 6 it becomes 4, 2, and ultimately 0. The vertical component changes because the vertical component experiences acceleration due to gravity. Acceleration due to gravity is towards downward facing towards the earth, right? This is the direction of G. It is in the direction of the vertical component. So only the vertical component experiences acceleration due to gravity because they are in the same direction or in the opposite direction, right? When the vertical component is opposite to G, there is a deceleration. When the vertical component, as the object will move this way, the vertical component will be in the same direction as the value of G. So there will be an acceleration. So vertical component is decreasing as you are going up. It is increasing as you are coming down, because when you are going up, vertical component is opposite to G. Vertical and G, they are opposite as you are going up. After the topmost point, vertical and G, they are in the same direction, so acceleration happens. Deceleration for the first part, acceleration, right? And the horizontal component, it does not get affected by G because the horizontal component and G, they are at 90 degrees. When at 90 degrees, the vectors do not affect each other. They do not affect each other. Right? So horizontal component stays the same throughout the journey. The horizontal component, say that the horizontal component has a magnitude of 2, it will stay 2 all throughout because h is not experiencing any gravity. Gravity and horizontal component of the velocity, they are at 90 degrees, they do not affect each other. So I've just explained a bit of the theory, which you'll find in the theory videos, so that you have a revision about it. So this graph here is a graph of the vertical component versus the time. Alright, and the vertical component reaches 0 at time t is equal to 0.6. So what is happening? At time t is equal to 0, the vertical component was, at time t is equal to 0, the vertical component was around, looks like 5.9 or 5.8, let us call it 5.9. It is not precisely 6. If you zoom in, you'll see it is not precisely at 6, it is slightly below 6. So let us take it 5.9 meters per second. At the topmost point, what happens? The vertical component VV is 0. What is this time? This happens at a value of time t when time t is 0.6 seconds. Alright, time t is equal to 0, high vertical component, time t is equal to, when it is at the topmost position, vertical component as 0. This much we have understood. Let us now go through the questions now. Complete this figure. So they are talking about this graph, okay, for the time until the ball reaches P. Until the ball reaches P. So how much is the acceleration till the topmost point? How much is the acceleration till the topmost point? It is minus g, because the movement is upward, which is in the opposite direction of the gravity. Gravity is downwards. Acceleration is minus g, and when you're coming down, your acceleration is g. Same acceleration, magnitude I would say, but not the sign. When you're going up, you are decelerating with g as the acceleration. When you're coming down, you are accelerating with the acceleration of g, which is 9.81. Acceleration has to be the same. So how would the graph look like as you are coming down? It will be an extension of the graph. Extension. So after the topmost point, the vertical component changes in direction. Earlier it was upward directing, now it is below directing. It will keep moving negative. It will keep extending in the same direction like this. So earlier the velocities were all positive. If you are taking the upward direction as positive, they have taken the upward direction, although your wish here, their wish is to take the upward direction as all positive. So downward direction will be all negative. So when you are going up, all the velocities are positive. When you're coming down with the same acceleration. But if you see that the velocity values are negative now. Negative. It's the same straight line extension. So if you have 0.6, you will move 0.6 here as well. So this, it will reach about 5.9 here. 5.9 it will reach here at a value of, so the magnitude, so you have to understand, it will extend till this point. It starts from 5.9. So this point coordinate should be my mistake. We write the x value first. So 1.2, which is a double of 1.2, which is a double of 0.6, and 5.9, a negative 5.9. Right, this is a negative sign. This is what you have to draw. So let us look at the mark scheme. If you see straight line from 0.6 to this, or VV, the final velocity is minus 5.9 at time t is equal to 1.2. The line is for negative values of vertical component of V. Read it, pause the screen and understand it. So this is how you do this question. It's a 2-mark question for this graph, completion of the graph. Second part, calculate the maximum height reached by the ball. What is the maximum height reached by the ball? Here you'll have to use the equations of motion. So let us make a note of the values that we are given. So let us talk in terms of only the vertical component. Only the vertical component. Initial value of the vertical component was given to you. It is 5.9. Initial value of the, remember it, be careful, we are talking only about the vertical components. Initial value at time t is equal to 0, it's 5.9. V at time t is equal to 0, right, 5.9. And finally this is at time t is equal to 0, right, and finally at time t is equal to 0.6 at a later point of time. What is the vertical component? At the topmost point, because you have to talk about the maximum height reached, right? So we'll talk about the vertical component at the topmost point. It is 0. Remember that both u and v are the vertical components. Initial vertical component, this is your initial vertical component and this is your final vertical component. You know u, you know v, you know the time interval, which is 0.6 minus 0.6. You know time value, time interval is 0.6. What else do you know? You know the value of acceleration, which is minus g or minus 9.81 meters per second square. Which formula do you think for calculating S makes sense? Let us go through the equations of motion. You can use the first formula. You can use the second formula. You can also use the third formula. All the three formulas make sense. You can use any one of these formula. I would suggest try it in your free time, use all the three formulas, you should be getting the same answer. Let us check the mark scheme, which formula they have used. They have used the most used formula for calculating S is ut is equal to half at square. So substitute your values in this equation. Substitute the values and you should be able to get your value of the height reached. So what is the answer here? It's 1.77 meters or 1.8 meters. Alright, so try using, I'm keeping this question open-ended. You can use any of the formulas, whichever you wish to use, like, and then use it. You should be getting the same answer, which is 1.8 meters as your answer. Now we are coming to the next part of the question, the third part. Calculate the horizontal component of the velocity of the ball at time t is equal to 0. At this time, calculate the horizontal component. Now this comes from finding the components of the vectors, right? How do you solve it? What is the vertical component? It is v sine 60. So how much is v? 5.9. We know that the velocity is 5.9 at time t is equal to 0 over sine 60. So how much is the horizontal component? V cos 60. So how much is v? V you have already calculated here. Substitute it in this place. You should get 5.9 cos 60 over sine 60. Solve it in your calculators. It should also be same as 5.9 over tan 60. Let us check the mark scheme. Are they also doing the same thing? Yes, 5.9 over tan 60. Your answer should be 3.4. So I'm leaving all the calculator work for you all to do. Pause the video for a while. You should be getting your answer as 3.4 meters per second. It is velocity, so the unit is meters per second. Alright, so this is done. And now the fourth part on this graph. 2.2 is this graph. Sketch the variation with time t of the horizontal component VH and label this sketch VH. 3.4 is what you have to label. So horizontal component does not change. This is what I explained in the beginning of the video. If you do not understand, go through that part of the video again. So 3 would be somewhere here. 3.4 would be somewhere here. 3.4, sorry. 3.4 would be here. So your graph would be a horizontal line which represents VH, which is 3.4. This is done. Verify your answers. If you're working it somewhere different from mine, please do comment in the chat box and let me also know and understand it. It will be more knowledgeable for me as well to learn from you all. The ball has a mass given to you. Calculate for the ball the maximum kinetic energy. The maximum kinetic energy. When do you have the maximum kinetic energy? When you have the maximum velocity. Where do you have the maximum velocity? You'll have the maximum velocity at the starting point because you're just getting a push. So you'll have the maximum velocity at this point, and V is something that we have already calculated. This is your V. If you solve it, you'll find that the value of V is 5.9 over, let me copy this, let me highlight this, this is your V, right? I'm just going to copy it, 5.9 over sine 60. Initial velocity was 5.9 over sine 60 degrees. Calculate it in your calculator. You should get the value of V and then use the formula for the kinetic energy, which is half mv square. Mass is given to you. Velocity you will calculate from here. You will get your answer. So here, pause the screen for a while. Do your calculations. I'll show you the mark scheme as well. Here is the mark scheme. The value of V you'll get as 6.81. I did it on my calculator and it was 6.81. So you'll see 6.81. So here it becomes half times 0.6.81 square. And when you'll do it in your calculator, you'll get your answer. Tally your answer, it should be around 15 joules, 15.1 or 15 joules. Fine. Now the maximum potential energy above the ground. When do you have the maximum potential energy? When you have the maximum height. What is the formula for potential energy? M, G and H. What is M? 0.65. I'm substituting the values in the equation and then you can use your calculator to calculate it. G is 9.81 and how much is the height? Height we calculated already. Where did we calculate it? Yes. Height was 1.8. Substitute this value. Solve it in your calculators. All of you, pause the video, solve it in your calculators. Are you getting this answer? If your answer is 11 or 11.3 joules, you are correct. Alright. So this was your question. Another questions on SUVAT equations. here is your mark scheme. I'm opening and keeping the mark scheme open for you all to go through it and understand the mark scheme as well. In the next video, we'll be taking up question number 3. Thank you.